I have a plan for today, as I usually do. I don't know how it's going to go. We shall see. So Griffiths does a bunch of stuff in sections 2.3, 2.4, and 2. I believe 5. Okay? So there are many sections that he goes through, and he goes through them individually one by one. What I find difficult to think about when I do it that way is I lose track of where I was, and I just get into the trees and I forget to look at the forest. So my plan for you guys is to give you the forest and let you explore the trees. Okay? So I'm going to smush sections 2.3, 2.4, and 2.5 all together. And I'll give you the big picture of all of it, which basically means is a lot of those mathematical derivations, I will leave them onto you to do. So if everybody could just take out your Griffiths, if you can, just look through the sections after class today and try to piece together where each of these words fell so you can see them for the trees. Okay, so let me explain to you what I mean. I'm going to start with curls and divergences. So I'm going to say, what was divergence?
The spread.
Excellent. And how did we mathematically do the spread? The dot product with an operator called del, right? How did we do the curl? What is the curl? Right? The rotation of something. And how did we mathematically define the curl? The cross product, right? It was curling and it was a cross product. So when I'm looking at electrostatics, that means I have del dot E as a field. And when I do curl, that will be del cross E. Mathematically, del dot E is given as rho over epsilon naught. And del cross E in electrostatics is given as 0. Why? Because if you pay attention to what your field does, it does this. Then it becomes smaller, then it becomes smaller as you go out. So it diverges depending on its charge density divided by epsilon naught. But it doesn't curl. Okay? The only time that it curls, the curl is not 0, is when we put in a B field. So I'm just going to tell you that this is always not true. The del cross E is not always true unless you have a changing magnetic field, and there will be a minus sign that's added onto it. So for electrostatics, the word electrostatics means what? The charges at rest. When the charges move, they form a current. That current creates a magnetic field, and so hence there is a curl present. This is also called the Faraday's law of induction when you write it this way. I know we won't deal with it until like chapter 5 or something, but I just wanted you to be aware of the fact that this happens. So when things are not moving, they're stationary, your curl is 0. So a changing magnetic field will create a curl of the E field. Okay? Just giving you that. And that also will develop Maxwell's equation. Oh, by the way, it also makes Maxwell's equations. Okay, so that is one thing. Another thing you should be aware of is what happens in a vacuum. In a vacuum, what's the charge density? 0. So that means rho goes to 0. That means your divergence is 0. Just giving you all of these formulas all at once, so you can see the progression of them in the multiple situations. And I also want you to write something. Changing magnetic field produces rotation. And it goes back here. When there is no B field, magnetic field that changes, it creates no rotating electric field. And so del cross E will go back to being the first equation we wrote.